Hello everybody. Today I'm going to show you how we use Juniper Contrail Cloud and Netronome Agilio SmartNIC to accelerate Affirmed Networks mobile content cloud. Looking at the agenda, first I'm going to speak a little about Affirmed's MCC, Contrail Cloud, and Netronome SmartNIC. Next we will see the architecture of the mobile content cloud, the topology that we use for testing, a short video of the test run, and the summary. Let's start with Affirmed's mobile content cloud. The mobile content cloud is a fully virtualized evolved packet core solution where all functions from the radio to the LAN are virtualized. It's a highly secure, cost-efficient solution that offers excellent performance, scalability, and carrier-grade reliability. All of this put together makes it a disruptive technology in the mobile operations space. Moving on, Juniper Contrail Cloud is a vendor-agnostic cloud orchestration and management solution. It's a robust solution built with scalability and high performance in mind. It comes bundled with intelligent automation and powerful analytics. With Contrail networking, it is simple to build a highly available, policy-driven infrastructure. Finally, the Netronome Agilio SmartNIC is a PCIe network interface card which accelerates Contrail's vRouter data path. Processor-intensive functions such as virtual networking, virtual network functions are now offloaded from the kernel to the NIC itself, thus saving valuable CPU resources. Now let's have a look at the MCC's architecture. The MCC consists of a number of virtual network functions, which are denoted by different colored blocks in this diagram. These virtual network functions are capable of call initiation, call processing, charging, billing, providing security, filtering, and a host of other functionalities. Let's take a look at the topology used for running the tests. We have a Contrail controller talking to the Netronome compute and the kernel compute. Compute-intensive processes, such as the SSM, runs on the Netronome compute. The Netronome compute is connected to the switch via a 40 gig link, and the switch is in turn connected to a gateway using a 20 gig link. The gateway is connected to the traffic generator through a 40 gig link. The traffic generator simulates the user endpoints, in this case, mobile phones. The mobile phone sends a HTTP GET request to the internet via the SSM VNF and downloads a 1 MB page as a part of the response. Now let's run the tests. So here in the test suite, I have two 10 Gbps tests running simultaneously to achieve a total throughput of 20 Gbps unidirectional. I've set the maximum concurrent flows to 8000 and flow creation rate to 2000. On the Netronome compute, which is hosting the SSM, I'm monitoring for flow statistics and interface rate statistics. And from the MCM window, which is my management VM for the cluster, I'm monitoring the subscriber count and also the cluster health. Let's start with the first 10 gigs of traffic. We can see that the flows are steadily building up and the GTPU tunnels are being established, which is indicated by the subscriber count. After subscriber count reaches 100,000, we see that the traffic is being pumped in. Now let us start the second set of traffic. We will see that after 200,000 subscribers are set up, the additional 10 Gbps of traffic is pumped in, thus resulting in a total unidirectional traffic of 20 gigabits per second. Let's also take a look at the I/O and core handlers on the VNF which is processing the traffic. We see that the average I/O utilization is around 48% and the average handler core utilization is around 71% for 20 gigs of traffic. From the interface summary, the total bandwidth coming in is almost the same as what is going out. From the testing window, we see that there are no failed transactions and we are receiving about 20 gigs of traffic in total. We can also verify the traffic on the gateway, and here we see that the traffic is equally load balanced between the two interfaces. The HTOP utility on the Netronome compute gives us the CPU utilization of the vRouter agent. As we can see, cores 1, 13, 14, 15 and their hyperthreads 25, 37, 38, 39 are at around 50% utilization. Let's wait for the test to be complete and we can go over the summary. So to summarize the test, we simulated 100,000 user endpoints and 16,000 user endpoint connections. We offloaded the Contrail data path to Netronome SmartNIC, and we also tested 20 Gbps unidirectional traffic without any failures. This test validates Affirmed's VNF on Juniper Contrail Cloud and Netronome SmartNIC with full SDN functionality. Thanks for watching.